Welcome back to the EXD. Somewhat surprisingly, we have reached episode 6, so I thought this might be a good time to pause and take stock and go over what we have covered so far and where we are heading. The goal of the EXD is to build mastery in AI, but with a top-down approach. So instead of starting with theory and simple networks, etc., I really wanted to see if we could start with a recent cutting-edge LLM and open it up to see if we can understand how it all works inside. You can think of this as a radical DIY hacker kind of approach as opposed to the standard academic progression from basics to advanced topics. My name is Ram and I work at the Ethereum Foundation on AI Ops. And this is an open learning log that I call the EXD. To start at the beginning, check out episode 1. I'll link it in the description below. Okay, let's start. This is going to be a short one. So we first kind of took a look at the setup. Essentially, I have my dev machine. It's called Yoneda. That's the one on the left. And I have a dedicated AI server. It's a gigabyte AI top atom, which is basically gigabytes NVIDIA DGX Spark implementation. So essentially, I kind of keep this machine clean. It's just running the servers that we want to play around with and the models. And I kind of do all my benchmarking and experimentation and workbench kind of stuff on Yoneda. If you're following along, you could easily, and you don't have a separate machine, you could easily do this on the same machine with a Docker container for your sort of AI server. Then we took a look at peeling the LLM onion, so to speak. So mostly we think of LLMs as being sort of these black boxes. You send text into them and they send text out. So we peeled just the first layer and we kind of got a sense of what the large parts are inside, So essentially we know now that users send text inputs. These inputs get tokenized. We didn't look very deeply into that, but we kind of glossed over it. But LLMs think in these tokens. So these tokens are then sent to the model and inference happens in 2 phases. First is a prefill phase where your entire prompt is processed all at once. So for example, let's say you have a document and a query about that document. All the contents of the document and your query hit the neural network and pass through it in one go. And then the decode loop starts, where the LLM starts to answer your query one token at a time. So it spits a token out, that token is appended to your entire document plus your query, now plus one token, and then that passes through the model. And then it spits another token out, and that is appended to your entire document, the query, your first token, and the second token, and then that gets passed through. And this continues until it either runs out of its output length parameter or until it hits what's called a stop token. And essentially the model has decided that it's done answering your question. This is then converted into a text output and returned to you. So this was sort of, we did this on a Qwen 3.6 model, one of their latest mixture of experts models. And we also, once we understood that these are the different phases, we began to take a look at how it works. So this was sort of an interactive, we got a sense of what the different parts are. We understood how the prefill phase differs from the decode phase. We understood how the different resources of a machine, this is like an abstracted computer, right? There's a CPU, there's RAM, there's GPU compute, and something called VRAM and KV cache. This is kind of the RAM that the GPU uses. And we understood in more detail how the prefill and the decode parts are actually very different. How prefill is very compute dependent and how decode is actually memory dependent, because it has to keep, it just generates one token at a time, but then it has to append it to the list of tokens that are being generated and then do a lot of fetches and pre-fetches to make sure the GPU is ticking along efficiently. And so we got a sense of how these two phases are actually very different, have very different performance profiles before the output is produced. We took one step further, just because it's a newish technique, but now seems to have become fairly standard with any sort of production serving of LLMs. We looked at something called speculative decoding, and this is now entering the realm of, once we understand how the different phases work, especially in performance terms. Sorry, 1 second. Sorry, there was somebody at the door. We looked at one technique for improving the performance of the decode step. Essentially, this speculative decoding uses two models, a draft model, which kind of guesses ahead very quickly, and due to a quirk of LLM architectures, the full model is actually able to verify all the guesses of the draft model in one pass. So you kind of get a little model to quickly make 2-3 guesses, and then get the big model to verify it all in one pass. So for example, in the 2-token scenario, the draft model guessing these 2 tokens takes less time than the full model would have taken to guess 1 token. And then, so this entire process happens in less than 1 token, the time taken for 1 token. And then the 2 guesses are sent to the full model and it gets verified in one pass in the same time that it takes for 1 token to be generated. So the overall time taken is a little less than 2 passes of the full model, essentially. Kind of. This is a little hand wavy, but essentially that's what we're looking at. Which is kind of cool. We kind of already are looking at some of the more interesting concepts at arguably a higher level, at a more superficial level. But this kind of gives us a sense of the lay of the land, what the different pieces are, and some of the methodologies that are already being implemented. Which kind of takes us to a small conversation I want to have about the way of the EXD. Just kind of reflect on this approach. I don't know about you, but I've kind of always struggled with the long slog from theory, which is no doubt interesting in itself, but from that to the really useful, awesome things that we work with every day. So if you wanted to learn about LLMs and start with perceptrons, it takes a while to kind of get through from, the absolute basics to something, a beast like Qwen 3.6. And what we're really looking at is, can we do the opposite? Can we start with the Qwen 3.6? And we've basically peeled just this first layer that you can see here. So you can see this is some kind of big machine, and there's like maybe some integrated circuits, and you can see like a PCB board or something over here. We're kind of at that level of abstraction right now. But as we peel each layer, the goal is to do 2 things. We want to peel it with an objective in mind. We don't want to kind of blindly peel it. So for example, it was useful to learn about speculative decoding because it helps us improve the performance of the LLM. So we have a tangible, useful outcome. And we're learning in order to understand how to achieve that outcome. I kind of like this approach. You work with things that are already useful, and B, everything you learn, you can immediately apply to improve what you're working with. So far, I think this has kind of been borne out, and I hope that the rest of the EXD, as we peel this LLM onion layer by layer and get to the real hardcore concepts inside, I hope this keeps happening. All right, with that said, let's start with the next layer of this onion. We already looked at these kind of big chunky pieces that an LLM inference pass is made out of. And next week, we'll start a deep dive of the first step, tokenizing. This is actually surprisingly and incredibly deep. I think going to lead to some pretty deep insights. So, yeah, meet you guys there next week. Tokenization deep dive begins. Cheers.